So let's talk event handlers. Now, these don't get talked about a whole lot, but they are fantastic for adding a little bit of functionality, some polish, and just some general juice to your game. And if you look for solutions for some of these ideas like pop-ups and double clicking and hovering over objects, there's a lot of different solutions on how to achieve that behavior. And a lot of them are more complicated than they need to be. In particular, I've seen some really complex double click solutions. And we're going to talk about that along with the event systems and event handlers in this video. Now, it's important to know that the event handlers work with both the old input system and the new input system. They also work with scene objects, and with one caveat, we're going to have to add another thing into our scene. And they also work with UI objects. So they work all over the place, making them really powerful to add, again, polish, juice, and functionality to your game. So the first thing we're going to create is a UI pop-up menu, meaning we move the pointer or the mouse over an object and a window pops up with some information about that object or something that we can do with that object. So to get started with that, I'm going to create a new script. I'm going to call this thing, let's create it first here. We're going to call this UI pop-up on hover. Now, this is going to be pretty simple. This is just going to pop up a window when the mouse enters and close the window when the mouse exits that object. Now, you might want something a little bit fancier that's got a right click, or maybe it's got a delay in it. Those things aren't all that hard to add or tweak. Into our script here, the first thing we want to add is Unity Engine, if I can type, Unity Engine.event systems. And this gives us access to the interfaces that we're going to implement for these behaviors. And in our case, we're going to implement IPointerEnter and IPointerExit. I'm going to then use Visual Studio to implement these like so. And again, that just ensures that I have the correct name of the function, the spelling's right, and the input parameters are correct. What I'm going to do with my particular implementation is pretty simple. Now, it's very possible that when you mouse over an object that multiple systems might want to know about that. Maybe you want to play a sound effect, maybe there's a particle effect, maybe the UI needs to react. There's a wide range of things that could be useful. So rather than hard code in behavior here, for this example, I'm going to add in an event. I'm going to add in public static event and system.action like so. And then we need to choose the input parameters or the information that we're going to send with this event. In my case, I'm going to send in game object, and I'm also going to send pointer event data like so. And that pointer event data, and we'll talk about it, but that contains a lot of information about the pointer, as the name would suggest. So, and I'm going to call this onPointerEnter like so. And then when the mouse cursor leaves this object, we're also going to call another event. So I'm going to do that, public static event system.action. And in this case, I'm just going to use the game object. I'm not going to send the pointer data. You can if you need to. And we're going to call this one onPointerExit like so. Okay, so here on onPointerEnter, all we're going to do is see if there's anybody subscribed to this event. If there is, we're going to invoke that event, and we're going to send in this game object and the event data like so. Very similar on the onPointerExit. onPointerExit, check if anybody's subscribed. We're going to invoke, and we're going to send this game object. Now, I don't know that I'm going to make use of sending that game object on PointerExit, but again, it might be useful to know. I could turn off some effects around that object. Maybe when you hover over this object, there's some additional particle or some sort of other effect to indicate that you're hovering over it. This could help turn that effect off. So that's it. That's all we're going to do here on this UI pop-up on hover. Again, pretty simple. And if you're not familiar with actions and events, check out my earlier video. I'll definitely post a link to that down below. So back into our scene here. I'm going to come to my plane, and I'm just going to put this on these three objects, the blue capsule, the pink sphere, and the yellow cube. I'm going to drag and drop that on like so, and we're almost good to go. Now, since we're doing this on a game object, we do have one more step. And that is to come here to our camera, which I've tucked away here, our main camera. Don't care about the camera itself. Don't care about the post-processing. But what we need here, and I've already added it from some testing here, is this physics raycaster. This is going to enable the event system to raycast into the scene and get raycast results, which is how the system is working, from scene objects and not just UI objects. So you have this event mask here, which is choosing which layers this physics raycaster can interact with. Now, for a basic scene like this, it's not too complex. I've just turned off the UI. Not necessarily a great reason for that. But in other examples, like my personal game, I have units that have a child object with a collider on it. And that collider functions as a radar or a sensory detection of when enemies get close to it. And I needed to put that object on another layer. And I needed to make sure that this physics raycaster was not hitting that particular layer. Otherwise, it just wasn't getting the proper interactions. It just wasn't working right. So if you're getting some weird behavior, definitely come and check this event mask. All right, we've got the physics raycaster on the camera. We've got our scripts on the capsules. So that's great, but we're still not doing anything. We don't have a listener for this event. And we're going to do that with a additional script that's going to be on the Popup UI itself. So let's take a look at that UI. So what I've got here, Popup UI, let's go to our scene view here. We can see what this looks like, and it's blank because I've got a canvas group here. So I really like the canvas groups. It's a great way to effectively turn an object on and off by setting the alpha to 0 or 1 or somewhere in between. And you don't have the overhead of turning the object on and off. It's just tidy. The scripts still work. It works really nicely. So what I've got here is just an image and then 2 text children. In this case, I'm using TextMesh Pro. First one is just a header, not going to do anything special with it. The second one, this is where we're going to populate some information about the object that we're hovering. So you can see here, that's just a text box, nothing too special. And the code itself, the code that we're going to create next is going to go on this Popup UI object. And this is going to subscribe to those events that we just created, grab some of that information, make use of some of that information, and place this pop-up in the right part of the scene and populate that text component with some information. So let's create a new class, new script, and we're going to call this UI Popup Menu. So in here, I'm going to add in TextMesh Pro since I'm using that. If you're not using TextMesh Pro, you probably should be, but you don't need to add that in. And I'm going to get rid of our start and update functions as well. Okay, what I'm going to add in here is a on enable like so. And in here, what I'm going to do is subscribe to those events. So on IPointerEnter, I'm going to add in display info. We'll create this function here in a minute. UI Popup on hover, on IPointerExit. And this is going to close the window like so. Likewise, we're going to create an on disable. Here, I'm just going to copy these 2 lines, paste them down here, and switch the pluses to a minus. That way, if this object turns off, we unsubscribe from the event and we avoid some errors. Pretty straightforward there. Then I'm going to again have Visual Studio create these functions for me. Next thing we need to do is we need to cache a reference to our canvas object. So canvas group, I call it CG like so. And then in our on enable, we're just going to do this quick and dirty, this get component canvas group like so. Okay. And then in the close window, we're going to do CG alpha equals 0. So all that's going to do is turn the alpha off so it can't be seen. You may want to toggle off the interactable and block a raycast, just depending on your implementation. I think when the alpha goes to 0, it won't block any raycast, but if you have different results, you can definitely toggle those here in the canvas group. All right, onto the display information. So in here is where we are going to do some work here. So hover object like so, and we're going to rename this pointer data like that. All right. So in here, what we want to do is a few things. We want to set the position of this UI pop-up, which isn't too hard to do. We're going to do that with this transform.position. That's going to equal event event data, oh, sorry, I called it pointer data. Let's actually call it correctly. Pointer data position. And that's going to be the position of the point itself, which we could leave it like this, but it's going to be a lot more user-friendly and nicer for the player if we offset it a little bit. So I'm going to add in a new vector 2. And in my case, I'm going to offset it by 300 in the X and 0 on the Y. This is, again, another case where if you want to be a little bit more sophisticated, these numbers should probably be proportional to the user's screen and resolution. My case, I'm on a 4K screen. That works pretty well. Your mileage may vary. Next, what we're going to do is make sure that our canvas group has an alpha of 1. That way we can see what's going on. And then after that, we want to display some information about this object. So let's go up here. Let's get, we're going to do a serialized field to keep things easy. I want a text mesh pro UGUI, and I'm going to call this info text. And we're serializing that field, so we're going to assign that in the inspector. Just keep it simple and clean. Then down below, we're going to do info text.text, and we're going to do hover object name like so. Then we're going to add in info text.text. I'm doing these on separate lines. You don't have to. I find it helps my thinking a little bit. I'm going to add in a new string here, and we're going to start a new line. So we're doing that with the /in, and then say the position. And then in curly braces, we're going to put in hover object transform.position like that. So that's just getting in, not terribly useful, but it serves a purpose of demonstration. We're just going to show the position of that object. And then again, we're going to do the same kind of thing down here. Add in a new line. And here we're going to show the rotation. Hover object transform.rotation. And let's do it in Euler angles. Pretty simple, works pretty well, but let's go give it a test and make sure everything works. So I'm going to take that UI pop-up menu and drop it onto the parent object here. And then I'm going to drag this info text into our slot like so. And last thing I'm going to do is turn my canvas group down to 0 like so. So it's not going to show up in our scene until we hover. Let's go into play mode, and hopefully we get a pretty decent result. So there we go. We got a pop-up. We can see it's a blue capsule. We can see its position. If I come over here, I got a pink sphere, and I've got a yellow cube. And again, this won't work on the stars. It doesn't work on the plane. It's only working on objects that have that UI pop-up on hover, which again gives us nice granular control of what's going on. When I was building my last game, Grub Gauntlet, I got some feedback. I had these buttons at the top that when you clicked on them, they would add an item to the scene, and then you could drag it around. But it would put the item right in the middle of the scene, which was great, or right in the middle of the screen, rather. And that was great for the game jam. That was great for early development. But it's not the most user-friendly, and it's not the most intuitive. So the suggestion came in to make it so you could drag and drop from that button. I didn't really know how to do that, and it turns out actually not that complex. So that's what we're going to do next. These buttons up at the top left of my screen here, the add cube, add capsule, add sphere, we're going to add a piece of code there so we can drag and drop from those and add an object to our scene. So let's take a look at those objects. And what we've got here is buttons. They don't actually have to be buttons. They could just be images. We've got our image here. We've got the text in it. Nothing special, just a generic button. So to add this functionality, we're going to add in a new class. I'm going to call it drag and drop, like so. And we're going to open that up. And just like before, we're going to add in the using statement, Unity Engine.event systems, so we get access to those oh so useful interfaces. So in this case, we're going to add in 3 different interfaces. The first one is IPointer down. And we're going to have the IPointerUp handler. And the last one is this IUpdateSelected handler. And that is going to be a little bit of our secret sauce and keep an update function out of our project. That is going to essentially function as an update, but only under certain conditions. Then just like before, we're going to get rid of the start and update. We just don't need it. I'm going to add in a couple fields here to get started. The first is a game object, and this is going to be the prefab that we're dragging into our scene. And second one is, once again, a private game object, and this is the object being dragged. So we want to be able to keep track, hey, what object are we dragging versus the other field, which is just going to be a reference to the prefab. So let's implement these interfaces here. So in the on pointer down, so this is when we click on that object, we're going to set object being dragged, and we need to instantiate a new object, and that's just going to instantiate the prefab. On pointer up, so this is going to be when we're done moving that object. All we're going to do is say object being dragged equals null. And we're going to use the null state of that effectively as a Boolean. Are we dragging? Are we not dragging? Should we still be dragging? All the magic is going to happen here on the on update selected. In here, we're going to get rid of this. We're going to say if object being dragged is not null, then we're going to do a bunch of stuff. So what we're going to be doing in here is essentially ray casting and putting this object that's being dragged at the location or that hit point of that ray cast. Now you can pull out the traditional raycaster and raycast over, a terrain or whatever. But in my case, I'm just going to raycast to a two-dimensional plane that goes through the origin. And I like that because it's, again, really easy. I learned about it a couple months ago. I really, really like this. So what we're going to do, we're going to create a plane. And the way these work, these are defined by a normal vector. So a vector perpendicular to that plane and a point on that plane. In my case, I just want the X and Z plane. So I'm going to say vector 3 up, and we're going to do vector 3, 0. So our normal vector is pointing in the Y direction, in the positive Y direction, and our point is the origin itself. So the next thing we need to do is create our array. Now, this can be done with the new input system or the old input system. I like the new input system, so I'm going to do it with that. To make that work, I'm going to come back up here and use another Unity engine or make another using statement, input system, like so. So with that added in, we're going to come back down here and add in an array, call it array. And this is going to go from the camera main, and we're going to go screen point to array like so. And what we're going to do here is going from the camera again to the location of the cursor. So if you're using the old input system, you can use input.mouse position. For the new input system, we're going to use mouse, current, position, read, we should be able to get read value, like so. A little bit more complex or a little bit longer, a little bit more verbose with the new input system, but still works pretty well. So next we're going to use the built-in raycasting of the plane itself, which I think is really slick, simple, and easy to use. So we're going to do plane.raycast, and we're going to put in the ray, out, float, distance, like so. So what this is doing is it's raycasting down to the plane, and it's sending out a float value, which doesn't seem terribly useful, but that is the length of the ray. And our ray itself, we can tell it how long or how far to go, and it'll give us the point at that distance. So a little abstract, but pretty useful all the same. So we're going to do object being dragged, transform, position. Autocomplete's getting a little aggressive there again. Ray, get point, distance, like so. So again, this is where the ray is giving us that point of contact where we actually hit that plane. And that'll work pretty well, but I'm going to give it a little bit of a vertical offset. So vertical vector 3 up, like so. And I'm going to multiply that by some value. Now that value, in my case, I'm going to use 1.5. That's going to keep my objects lifted up above the plane. You can adjust that value. You can also get fancier and use something like the bounds to set it just perfectly so that you're always just kind of skimming the ground. You'll need to adjust that for the effect that you want. And that's it. That's all we got to do. 30 lines of code. So let's save that, go back into Unity. And then on each of these buttons, I'm going to drag and drop that script. And then I'm going to add in a prefab into that slot. So I'm going to come up here to my prefabs. Where did I put these? Here we go. So we're going to add in a yellow cube. We're going to add in a blue capsule. and a pink sphere like so. Now, if I click and drag, you can see, I put the blue caps, I put them on the wrong thing, but nonetheless, you can see that I've added my blue capsule. I've added my cube, added my sphere. Now you may notice that when you first drag it out, you can't see it. And that's because we're raycasting way out. This plane is infinitely big. And as I bring the mouse cursors closer, the object itself appears to get bigger and it gets closer. We can see it like so. Pretty cool, pretty handy. Definitely room for a few tweaks depending on your implementation. But again, hopefully that's enough to get you started with the behavior that you want. So the next example I want to look at is double clicking on an object. Now, if you go searching for this, there are all kinds of solutions and I'm sure they work, but a lot of them seem far more complex than they need to be. They've got static variables, they've got update functions, they've got coroutines. It's way more complicated than it needs to be. These event handlers allow us to implement double click, or rather detect double clicking on an object very, very easily. So what I'm going to do is create a script that when we double click on these stars, those stars are going to spin. And just to add a little bit of juice, when we mouse over those stars, their scale is going to go up. And when we mouse off of them, their scale is going to go back down to the original. So let's create a new class. We're going to call this double click to spin. And to create that juice, that expanding scale and spinning, I'm going to be using doTween. You don't really need to. It's just a nice way to add in some juice. So just like before, we need to add in Unity engine.event systems. And I'm going to implement 3 different handlers here. The first one is IPointerClick handler. The next one is IPointerEnter handler and IPointerExit handler. Implement those. And I'm going to get rid of the update function, but I am going to keep the start function and move it to the top like so. Now, in order to do this change of scale when we mouse over or mouse out, we need to track the original scale of the object. So I'm going to create a private vector3 and call it start scale. So then, maybe no surprise, in the start function, we're going to say start scale equals transform.localScale, like so. All right, let's do the easy piece first, which is the scaling up and the scaling down. So to use doTween, I'm going to add in dg.tweening. And if you don't have doTween, I believe there is still a free version. The paid version is $15. I think it's amazing. It's a great way to add some juice to your game. TyroDev's got a great video on how to use it. I'll try to remember to put a link down below. Well worth the $15 if you're trying to make a game. So what we're going to do here is on IPointerEnter. What we want to do is we're going to do this transform do scale like so. And so the do scale is from doTween. We're going to be tweening here. And we're going to do start scale times 1.1. So we're just going to go 10% bigger than we currently are. And we're going to take just 0.15 of a second to do that. Pretty easy. Then on the IPointerExit, we're going to do something very similar. Once again, do scale. And in this case, we're just going to go to start scale because we want to go back to that original starting scale. And we're going to do that over the same time period like so. So that's just a really simple example of adding a little polish, a little juice to your game with doTween and these event handlers. But the real meat, the real point of this example is the double click. And this is surprisingly easy. So in here on the IPointerClick, we're going to do if event data click count equals 2. Yep, that's all it takes to detect a double click. We are going to do this transform, do shake rotation, and we're going to do it for 1 second. Now, again, I'm just going to like shake this thing. I'm going to spin it a little bit. You could obviously do something very different there, but that event.click count is all it takes to detect a double click. We put it in this IPointerClick function after we've implemented the IPointerClick interface. Piece of cake. No coroutines, no updates, no static functions. That's it. So let's save that, head back to Unity, and let's go to our star, add in our double click to spin, go into play mode. And you'll notice now that when I mouse over any of them, I get this nice kind of satisfying scale up, scale down, super nice and easy. And if I double click, I get a spinning rotation. I don't think it can be much easier to add juice and polish to your game than that. And the double clicking, piece of cake, no problem. So much simpler than most of the solutions that are out there on the interwebs. I got examples all day long, so we're going to do another one. Okay, so what if you want to drag an object around the scene? I've got this cube, I've got a sphere and a capsule. What if I want to move them around on that plane? I want to put them in a different location. Pretty common game mechanic. And it's a little bit more complicated, but it's not that hard, again, with these event handlers. So I'm going to create a new class, and we're going to call this move scene object. Just like our other examples, we're going to add in Unity engine.event systems, and we're going to implement a whole bunch of interfaces. We're going to do IPointerDown handler, onPointerUp handler. We're going to add in the IUpdateSelected handler, and to add a little bit of polish, the ICancel handler, like so. I'm going to delete our start and updates, and then implement these. So what we're going to be able to do here is click on an object, drag it around on the plane. I'm going to use the same trick as I did before, create a plane that we're dragging around on the two-dimensional plane. And again, if you have a three-dimensional terrain, you can do a different raycast and drag it along that as well. What we are going to add into this is this onCancel function, or this onCancel handler. And what that's going to allow us to do is when we press the cancel button, which by default is the escape button, we can cancel the movement and the object can go back to its original location. To do that, we're going to need to track its original location. So we're going to have a vector 3 and we're going to call it start location, like so. And all of this is going to start in the onPointerDown. So that is when we have now clicked on the object. So we're going to set start location is equal to this transform position, like so. That way we can move it multiple times and it's always going to go back to its last position. Then we need to do something here that's a little bit different. In order for the onUpdateSelected function to work, in order for Unity to know which object is selected, we need to tell it which object is selected. And that is true with scene objects. It does not appear to be true with UI objects, but since we're moving scene objects, we need to tell Unity what object is currently selected. And we do that with event system.current set selected game object. All right. And then on the onPointerUp, this is when we are done dragging it. All we need to do is say event system current set selected object to null. And that's just going to avoid any errors when we're done dragging. Unity doesn't still think that is the selected object, which can cause some unwanted behavior. Then we're going to come down here to the onUpdateSelected function. Again, this is where the magic's going to happen. This functions as an update function, but my understanding is this function only gets called when this particular object is selected. So we don't have the same overhead as a regular update function itself. Once again, I'm going to create a plane and we're going to do it just like we did before with vector 3 up. So vector 3 is 0. So we're once again creating a plane that is in line with the X and Z axis. We're doing that by defining the normal vector to be up and the point that we're going through to be the origin, or the world origin in this case. Once again, we're going to create an array, just like we did in the previous example, camera ray screen point. And from this case, we're going to go from, I need to add in mouse. Let's work with our autocomplete instead of fighting it. So we're going to add in Unity engine.input system. And again, I'm doing this with the new input system. Like so. And it works equally well with the old input system. You would just be using input.mouse position like that instead of mouse.current. Piece of cake, raycast, and we're going to raycast using this ray, out, float, distance, just like we did before. And scroll down here a little bit. This transform.position equals ray.getPoint distance. And once again, I'm going to give it a little bit of an offset in the vertical direction, like so. So this code here is nearly identical to where we were dragging from those UI buttons. The difference here is that we're using the onPointerDown and onPointerUp to control the selected object, which means that this onUpdateSelected function will run every frame. In the previous example, the button was the selected object, and so that function continued to run, which is why that was structured a little bit differently, and we needed to cache a reference to the selected, or the object being dragged rather, to know what we were moving around. In this case, we're calling this on this object that we're moving, a little bit simpler. All right. Last thing we're going to do is the on cancel. So here what we're going to do is we're going to say this transform position is back to the start location. And we're also going to say event system current set selected object, also set that to null because we're not moving that object anymore. Let's save that, go back into Unity. And once again, I'm going to go to just these three objects that are already in my scene. And I'm going to add in the move scene object script like so. And you can see our pop-up is still working, but now I can click and drag these objects around. No problem. They are physics objects, so they do interact with each other. But pretty slick, pretty easy. It's hard to imagine that there's a much simpler solution than that one. All right, so moving into a new scene here, and this one is more UI focused, but we're still going to be using the same event handlers. The first example I want to look at are the three boxes here on the top right of our canvas here. And these are just images. We can go take a look here. These are images. I've called them draggable UI. They're just images. And then the child is just the text object. And we're going to be able to drag these around. To be able to drag these objects around, we need to create a new class. So I'm going to do that. I'm going to call this drag UI, or let's keep our naming convention similar, UI drag. And we'll open that up. So again, we're going to add in our Unity engine dot event systems. And we're going to implement, in this case, I'm going to implement quite a few different interfaces here. First one is IBeginDragHandler, IEndDragHandler, IDragHandler. We're going to add in the IEnterHandler and the IPointerExit handler. Like so. And then we're going to quickly implement these. And I'm going to get rid of my update function. We're not going to need that. I'm going to keep the start function. And once again, I'm going to move that to the top for my own organizational. We're going to need a couple fields here, and they're both going to be vectors. The first one's going to be vector 3, and this is going to be a start scale. We're going to be doing something similar like we did earlier. When we hover over it, the scale can change. And we're also going to create a vector 2, which is going to be an offset. Now, this offset, what this is going to do is when you click on an object, it's going to keep the relative distance between the pointer and that object the same. If you don't use an offset, when you click on it, the object will just snap to the position of the mouse cursor, which if it's a small object isn't very noticeable, but if you have a large object and you're dragging it around, this is definitely noticeable. All right, in the start scale, we're going to do start scale equals this transform local scale. We're just going to cache that. And then let's make our way down here to the onPointerEnter. And here we're going to just tween it up. We're going to make it big like we did before. So let's go to the top and add our tweening like so. And again, this isn't necessary, but if you're going to make an inventory system, I think this little extra polish and juice of that scale going up is pretty nice. So let's go to onPointerEnter. We're going to do this transform local scale. Oops, that's not what we want to do. We want to do this transform.doScale like that. And we're going to say start scale times 1.1. So again, we're getting 10% bigger than we were before. And this time we're going to take 1/4 of a second to make that happen. On the onPointerExit, we're going to do a tween but that time tween back to the start scale like so, and we'll again take a quarter of a second to do that. Next, we need to work on the drag behavior itself. And we have these three functions: on begin drag, on drag, and on end drag. So on the begin drag, this is where we're going to set the offset. So we're going to say offset equals event data dot position. So that's the position of the mouse cursor, minus new vector 2, this transform position X, comma, this transform position Y, like so. And again, what that's doing is just getting the distance or the vector between where the origin of this object is and where that mouse cursor is, and setting that to our offset. Then in the on drag, we're going to say this transform position equals event data dot position. So again, the position of that pointer minus the offset. So that's all we really need to do to get the drag behavior working. But to juice it up a little bit and to show one more of these functions, one more of these event handlers, we have this on end drag. And here I'm going to choose a pretty lazy way to do this. We're going to play a sound effect. And I'm just going to play end of drag, which is just a sound effect that I've assigned to make a little noise when we finish the dragging. You could do other things here. You could play some other animation. You could play some particle effects. You could do a lot of things. But again, the main idea here is an example of what can be done pretty quickly and pretty easily. So back here in Unity, we're going to select our draggable UI objects and add in this component, the UI drag, like so. Go into play mode. We can see that we can move this around. And hopefully you can hear the sound effect is being played. Pretty easy, pretty simple way to be able to drag UI objects around your scene. Now, the last example I want to look at is the basics for an inventory system, where we can drag and drop objects around onto different slots. Now, I'm not going to go into creating stacks or splitting stacks or selling or prices or anything like that. Just the basics of how event handlers are used to create some of this behavior. And my hope is that that's enough to get you moving and rolling on your own solution for that. All right, before we get into the code, let's take a look at how this inventory panel is structured so you can duplicate it on your end, because sometimes UI in Unity can be a little frustrating. So here we have this inventory panel, which is just an image, and we've got a grid layout group and a content size fitter on there. That's just used to control the size of this image so that it fits nicely around our grid, and the grid itself creates, well, the grid. And if we open that up, you can see all the various slots. And these slots themselves are images with a vertical layout group. Now, you could use a horizontal layout group. That's going to work perfectly fine. We just want a layout group that's going to grab the child object and center it. So what I've also done here is checked the control child size for the width and the height. I've also set a little bit of padding. You can see here how the pink, blue, and yellow items, there's a little bit of a rim around them, and that's just coming from that padding. So you can see that some of these slots have children. So if we open that up, you can see in here we have an inventory item, and that itself is just an image with itself has a child of a text object, just so we can label the inventory item. And these objects, this is what we're going to be moving around, and this will have additional code on it. And the bulk of the logic will be on these inventory items itself. So to get started with the code, I'm going to create a new class. I'm going to start with a simple one, which is the inventory slot. Name it like so, and open it up. I'm going to get rid of these first couple of using statements. And then, like we've been doing with every example, adding in Unity engine.event systems. And in this case, on the slot, all we're going to implement is the IDragHandler. That's it. Nice and simple. Implement that, and we're going to get rid of the start and update. Now, this onDrop function, all it needs to do is recognize that something has been dropped onto the slot, and then take that object and set it as a child object of the slot. And again, our event handlers and event data makes that pretty easy. So we can do event data.pointer drag, and this pointer drag is the game object that is currently being dragged around the scene. Take the transform of that, set parent, And what we want to do, I'm going to make this a little more detailed. This transform like so. And that's it. That's all we need on the slot for this type of behavior. And again, if you're wanting to stack objects, if you're wanting to be able to split objects, you might need more logic. But for now, this is all we need to be able to drag and drop a slot around. Go back into Unity. And while I remember, I'm going to add it to all the slots like so. And then next, I'm going to add in a new class. And this is what's going to go on the inventory item itself. I'm going to call this inventory tile. Open that up. And then in here, we're going to get rid of these using statements again. And then we're going to add in two more. The Unity engine.event systems and Unity engine.ui. I'm going to get rid of the start and the update functions. And then we're going to create two new fields. The first one is a vector2. It's going to be an offset, just like we did with dragging the other UI objects. We're going to have an offset so this object's not snapping to the mouse cursor. And we're also going to have a transform, which is going to be the starting slot. And what that's going to be used for is if we drag this object and we drop it on something that's not a slot, or, well, I guess that's the case. So if we drag it on something that's not a slot, we're going to want that item to go back to its original slot. We don't want it to just stick to wherever it's at. So we're going to be able to cache that, the starting slot where that object is. And I forgot, so let's add in our interfaces here. We're going to have IBeginDragHandler, IEndDragHandler, and IDragHandler. Implement all those. So let's start with the onBeginDrag, which gets called, as the name suggests, when the dragging begins. So first off, we're going to say starting slot is equal to this transform.parent. Pretty simple. Then what we need to do, we need to unparent this item because we want it to separate from that slot and we want to be able to drag it around. So this transform set parent null. And then most importantly, actually, we don't want to set it to null. Let's change that to this transform.root. So that will set the parent to the root object. Now, if your canvas for some reason is not the root object, you might need to adjust this logic. This is assuming that the canvas is the root object in your hierarchy. So with that done, the most important piece here is we want to set the sibling to be the last sibling, like so. So what these two lines are doing is we're unparenting this item and it's effectively setting its parent to the canvas and then setting it as the last sibling. What that will do is have the effect of always drawing this object on top of other UI objects in the scene, assuming you don't have more than one canvas. Then we need to get our offset. So offset equals event position data, or event data position minus new vector. This is just like what we did before. This transform position X, this transform position Y. Gotta love Visual Studio's autocomplete. And the last thing we need to do is we need to turn off the raycast target for this image. And I'll explain why we need to do that. So we're going to get the image like so. If I can type raycast target equals false. Now, the reason we need to do that is once we're dragging this object around the scene, we've already raycast to it. We've already grabbed it. We already know what object we are dragging around. So the raycast isn't necessary. But more importantly, when we then drag this over a slot and let go, the raycast needs to go through the inventory item and hit the slot behind it. That's how the onDrop function gets called on the inventory slot. If you forget the step, you'll be able to move it around, but it won't snap into a slot. All right, on to the onDrag. This is pretty straightforward. All we're doing here is moving the object with the mouse cursor, much like we've done before. So this transform position equals event data position minus the offset. Then in the onEndDrag, we got to do a few things. So number one, we want to turn the raycast target back on. If we don't do that, then we won't be able to pick it up a second time. So we'll turn that on like so. Then just for fun, I'm also going to play a sound effect, totally unnecessary, but it is kind of a fun thing to do. play the same sound effect that we did last time, like so. So the next thing we need to do, we need to check and see if we've been dropped onto a slot. And the way that works, if we go back to our inventory slot, this onDrop function gets called before onEndDrag. So if we have dropped onto a slot, we will be parented to a slot. So back here in the inventory tile, we're going to do if this transform dot parent dot get component inventory slots equals null. So if we've been dropped onto a slot, then we should be able to get the inventory slot component from it. So if it is null, then we're going to do this transform dot set parent starting slot like so. And again, the actual parenting to the slot is happening on the slots component, not here on the inventory tile. Save that, head back to Unity. I'm going to open up all of these slots where I've got inventory items, and I'm going to drop the inventory tile on it like so, and then we'll go into play mode. So I can drag this around. And if I drag it over here, it goes back to its original parent. Works pretty well. I am remembering that I forgot to talk about one thing here. So if we open up these inventory items, if I go to the text here, I have turned off the raycast target here. And again, that's the same reason that we needed to toggle the raycast target on and off while we were moving this object. If the raycast target is turned on for the text, it's possible that the drop won't be detected if you grabbed it on a spot that is blocked by that text. Small detail. And if you have more things in your inventory item, so if you have more images, subtext, you're going to want to turn off that raycast target, or you can also use a canvas group to toggle that off for all children of that object. So there you go. That's my video on event handlers. It's a great way to add juice and polish and functionality to your game. At the end of the day, I hope that was interesting and better yet useful for you and your project. If it was, think about hitting the thumbs up or leave a comment. And until next time, happy game designing.